Leading Ukrainian microbiologist Professor Alexander Tashyrev and Dr. Vera Govorukha visited 5th International Conference Ecological Engineering and Environment Protection, Plovdiv, Bulgaria. The topic of the report was optimization of mass transfer mode for hydrogen obtaining with maximum destruction of food waste. We have been working on the problem of biohydrogen obtaining for more than 20 years. As you know, multi-component solid food waste is the most abundant type of waste in the world. And now we can say that we are close to develop effective, environmentally friendly biotechnology for biohydrogen obtaining from multi-component solid food waste. Accumulation of such type of waste is acute all over the world. Such wastes are accumulated at the enterprises of food industry, and also they are the part of our household waste that is dumped in landfill. Of course, a lot of countries make tremendous efforts to solve these problems. But as you can see, the volume and the number of landfills still does not decrease. During our work, we usually face the misunderstanding that food waste consists of natural polymers. Therefore, its fermentation is not dangerous for environment. However, if these natural compounds are accumulated in environment in huge concentrations, they become toxic, environmentally hazardous substances. We'll illustrate this situation on the example of ethanol and volatile fatty acids. Everyone knows that yogurt is a food product with valuable medical properties. Concentration of ethanol can reach 1% in it. It is non-toxic to the organism in such concentration. In contrast, when ethanol concentration rises up to 96%, it becomes a deadly poison. The same situation is with volatile fatty acids. When they reach concentration 1000 ppm, they inhibit methane synthesis, and reaching the concentration 2 or 3000 ppm, they completely inhibit hydrolysis of polymers. Similar situation occurs with food waste. In huge concentrations, they become xenobiotics. Accumulation of huge amounts of waste leads to a number of problems. They are the following. First of all, it is direct accumulation of toxic food waste that occupy large areas near megapolises. Second, it is poisoning of atmosphere with toxic gases, such as hydrogen sulfide, ammonia, and mercaptans. Third, it is poisoning of soil with toxic filtrate. Altogether, it leads to environmental pollution, diseases of humans and animals, and destruction of ecosystems. Using our strategic and biotechnological approach, we can transform this ecologically hazardous waste into clean energy, biohydrogen or biomethane, alcohols, and solid fuel. So, the aim of our work was to optimize mass transfer mode to improve the efficiency of biohydrogen synthesis and destruction of multi-component solid food waste in batch reactor. For this purpose, we conducted the optimization of frequency of mixing. That means the ratio of duration of waste mixing to duration of pause. Optimization of the process cannot be reduced to study of only one parameter. We defined at least 8 key parameters. They are on the slide. To achieve high efficiency of waste fermentation, it is necessary to investigate the role of each one. Green market are the parameters that have already been optimized. They are redox potential of medium, pH of medium, and size of waste particles. Partially optimized parameters are marked with blue. They still need to be investigated in details. They include ratio, waste and water, mixing speed, and construction of reactor. Red marked are the parameters that are the subject of this study. The figure represents the horizontal batch reactor. Its concentration is optimal for work now. This reactor provides the most efficient waste mixing. Accumulation of biomass is a very difficult aspect of any biotechnology. We solved this problem by creating a dry granular microbial preparation. There are different modifications of preparation depending on type of waste. The preparation contains optimized concentration of microorganisms as well as nutrients and regulators of microbial metabolism necessary for their growth. Destruction of waste is a key aspect of any successful biotechnology. The figure shows high efficiency of waste particles degradation. Waste particle size was reduced 10 or 20 times during 4 days of controlled fermentation. On the other hand, spontaneously decaying particles remained their size for months. Biohydrogen synthesis and waste destruction were completely suppressed during fermentation of wood waste without mixing. Acidification of medium takes place at the beginning of waste destruction, so acidic metabolites inhibit microbial growth. Obtained engineering and technological parameters of fermentation confirm that. So, coefficient of waste destruction, that is the ratio of initial and final weight of waste, was only 4. Biohydrogen yield was low, it was only 14 liters from each kilogram of waste in terms of absolutely dry weight. Complete inhibition of the process was observed after 6.5 days of cultivation. So, mass transfer is necessary condition for biohydrogen synthesis and effective waste destruction. We managed to significantly improve the efficiency of food waste degradation and biohydrogen synthesis using the mode half minute of mixing and 60 minutes of pause. Under this mode, time detention was only 5 days. Coefficient of waste destruction was higher, it was 59. Biohydrogen yield was also higher, it was 44 liters from each kilogram of waste. So, it is obviously that mixing leads to positive effect. Maximum efficiency of hydrogen fermentation of waste was achieved under the mode 10 minutes of mixing and 20 minutes of pause. These results are promising for industrial application. Under these conditions, time detention was only 4 days. Coefficient of destruction was very high, it was 94. Biohydrogen yield was also high, it was 123 liters from each kilogram of waste. So, the mode 10 minutes of mixing and 20 minutes of pause was optimal. It provided the most effective destruction of waste during the shortest period of time. The highest yield of hydrogen was achieved. It increased in 9 times compared to the absence of mixing. Common way to use biohydrogen after fermentation is its direct burning. Pure hydrogen has too high temperature of burning, so it is quite hard to use it in ordinary conditions. The advantage of biohydrogen obtaining is the following. We obtain gas mixture that contains optimal ratio, 40% of hydrogen and 60% of carbon dioxide. It can be burned directly from the gas holder without pretreatment. We used copper wire to visualize invisible flame of biohydrogen. In addition, only non-fermented lignin cellulosic resides are remained as a result of fermentation. They can be burned and used as additional solid fuel. So, as a result, we can say the following conclusions. Mass transfer of culture medium is necessary condition for effective biohydrogen synthesis and degradation of waste. Mixing mode can affect metabolic activity of hydrogen-producing microbial community and duration of fermentation cycle. Mixing mode 10 minutes of mixing and 20 minutes of pause is optimal for effective synthesis of biohydrogen with maximum destruction of waste. It provides uniform distribution of components of medium that determine high engineering and technological parameters of fermentation. Obtained results are the basis for further development of profitable industrial biotechnology of environmentally hazardous food waste degradation and synthesis of environmentally friendly energy source, biohydrogen. Let me introduce our scientific team. The head of the Department of Extremophilic Microorganism Biology, Professor Alexander Tashyrev. Our microbiologist and biotechnologist, PhD Hanna Tashyreva. Me, PhD Vera Govorukha, and master degree student of National Aviation University, Olesya Havriluk. The problem of biohydrogen obtaining simultaneously with destruction of wood waste is acute all over the world. So welcome to cooperation to solve this problem. Thank you for your attention.
Thank you. Maybe there are questions.
Did you evaluate the cost efficiency of this process compared with the process of methanization?
The process of hydrogen fermentation is more effective. We didn't calculate the direct figures, but for our first calculations, we saw that hydrogen efficiency is much higher than methane. First of all, it is because the period of fermentation of food waste in this way is much more shorter. So first of all, there is much more increase and effective of this fermentation.
Maybe.
How do you sterilize the waste before the fermentation, before the inoculation?
The sterilization is not necessary for these conditions. We have to pasteurize this waste, and that is all what we do.
Maybe one specific addition to your question. Increase of mass transfer always means energy transfer, energy input. So still in your advice, have you measured how much mechanical energy was introduced into the waste to get this increase in mass transfer?
The measuring of mechanical energy will be the next step of our investigation. First of all, we wanted to find the optimal speed of mixing, the duration of mixing, and so on. And then we will calculate how much will be the cost in energy.
Yeah, thanks again.
Looking forward for further cooperation with scientists and businessmen in the field of environment protection and green energy.